in problem 10, we're told we have a package of 100 fuses. Now look, as soon as I see that word package, I'm going to draw my package, an urn or a box or whatever you like. And I know on the outside I'm going to put the total number of objects that I have. I have 100 fuses, and what we're told then is that 10 are defective. So that's what I'm going to put on the inside. The outside I'm going to put the total number of objects I've got. On the inside, I'm going to get the details and put what we have on the inside. And we are told that 10 are defective. So why don't we write it like this? We have 10 defectives, but there's 100 altogether, so there must be 90, and I'm going to write it in our set notation, not defectives. I could write good or NF for not defective, but the way I like to do, I like to keep the letters the same. So I got 10 defectives, 90 not defectives. And there's 100 altogether, and we're told we're going to choose a sample of size 5, so that's going to be our R. R is equal to 5. So just to summarize again, on the outside I'm going to put the total number of objects I've got, 100. How many we're going to choose, that's going to be my R, 5. And on the inside I'll put the details, right? Because this is what's on the inside. 10 defectives, 90 non-defectives. And part A asks us how many samples are there? So there's no restrictions here. I just want to know how many samples we've got. So there's 100 from which to choose, and we want to choose any 5 of them. So 100 fuses, choose any 5 of them. And when I did this one, it's another huge number. I got 75, 281, 520. In part B, what we're asked for is this. How many ways can we get 2 defectives? So I'm just going to write what I see, 2 defectives. But now, as we did back in problem number 4, what I want is I want to get these in terms of everything that I've got up inside this box. I want this in terms of D and the D primes. So to do that, we're going to have the number of ways. Now to get 2 defectives, if we get 2 defectives and we're choosing 5 altogether, that means we have to get 3 non-defectives. That makes sense? So to get 2 defectives, we have to get, out of 5 that we're drawing, we need 2 defectives, and then the other 3 have to be not defectives. And now that I've got the number in this form right here, I can just write it in terms of my combinations. I can just get my count. So we have 2 defectives, and there's 10 from which to choose. We want any 2 of those. And then go to non-defectives. There's 90 of those, and we want any 3 of those. So we really got the solution right here, but we could go ahead and compute it. So when I computed that one, I got this number here. I got 5,286,600. Now, in part C, we're asked how many of the samples contain at least 1 defective. Now, I'm going to do this 2 ways. Here's one way. This is kind of just the way of just grinding it out. And it's kind of what we did back in problem number 4. So I'm going to break this down. I'm going to break this at least down into exactly. So to get at least 1 defective, here's what we could do. To get at least 1, we could get 1 defective, or 2 defectives, or 3 defectives, or 4 defectives, or 5 defectives. Now let's take each one of these, and write this in terms of everything that we've got in here. So I'm going to use a square bracket this time. So it's going to be a number of ways we can get, right now I want 1 defective. So to get 1 defective, when I draw 5 items, I must have 1 defective and 4 non-defectives. Or, let's get this one now. To get 2 defectives, we would want 2 defectives and 3 not defectives. Or, now to get this one, 3 defectives, we would want 3 defectives, and then since we're drawing the 5, we need 2 more, and these have to be non-defectives. Or, now we want this one, 4 defectives. So to get 4 defectives, when we draw 5, we would have to have 4 defectives, and I have 1 left over. That would have to be a non-defective. Have to go down here on this line. And now finally, to get 5 defectives, we would have 5 defectives and 0 non-defectives. close, and close. Okay, now I can make all these individual counts. So let's do that using our combinations. So in the first one here, we're going to have, now we're choosing one defective. There's 10 to choose from. So we have 10, choose one. Out of 10 defectives, choose one of them. Then there's 90 non-defectives. Choose any 4 of those. And then it's an or, so that's a plus. Then out of 10 defectives, choose any 2. Out of those 90 non-defectives, choose any 3, plus. Now we come over here. Here's where we are, at 3 and 2. So out of the 10 defectives, choose any 3. And then out of the 90 non-defectives, we'll choose any 2. Let's go down here, plus. And then, now here's where we are. We're right up here. The 4 defectives, 1 non-defectives. So out of the 10 defectives, we want any 4. And out of the 90 non-defectives, any 1. And then finally, for this one here, the 5 defectives and 0 non-defectives. 10, choose 5, and 90, choose 0. And when I crank through all of these computations here with my calculator, I got this number here, 31,338,552. Okay, this is a lot of computing, and we're just kind of grinding it out. But wait, look at this. There's another, maybe more efficient way to compute this number, and this kind of shows up when we get into Chapter 6 in probability, this new method here. So let's take a look at this one. So what we want to do here is we want to compute the number of ways of getting at least one defective. Now, quite often, when you see this at least one, what you might do is think opposite. Now, what is the opposite at least one? We're going to choose 5 fuses, and we want at least one defective. The opposite of this is no defectives. So let's look at this count right here. What is the number of ways that we can get 0 defectives? And with our approach, remember what we're going to do is we're going to take this and look into our box and get every letter that appears. So what we want out of this is the number of ways of getting 0 defectives and 5 non-defectives. So when I compute this one, there's 10 defectives. We want 0 of those. There's 90 non-defectives, and we want all 5 of those to be non-defectives. And when I make that computation, I got this number. I got 43,949,268. Now, if you remember all the way back in Part A, we computed the number of samples that were possible. So the number of samples that were possible were, okay, what we're going to do, remember, we had 100 fuses altogether. We were just going to reach in and get any 5. No restrictions, just out of 100 objects, choose 5 of them. And we got this number here. And what we're going to do now is, if this is the total number, and we subtract this number, right, here's the total number of samples possible, subtract the number that have no defectives, then what's left is the number up here with at least one defective. So let's make that subtraction here. Here's the total number possible, here, minus the number with no defectives. And when we make that subtraction, we are going to end up with that same number that we got when we ground this out, 31,338,252. Maybe it's a little bit easier.